By now, we know that machine learning is great. I mean, it's awesome. We can create so much value for different use cases by feeding our clean and organized data into a learning medium, for example, a deep neural network. However, for many use cases, we need more sophisticated models. For example, deeper networks with funky architectures. Since there are so many different parameters that can be tweaked in these types of models, it will take a long time and a lot of data and computational power to get good results. For example, millions of dollars are spent in R&D at Google, Microsoft, etc. to build these state-of-the-art models that we have today. And this data speaks for itself. Not everyone can do this. And this is where transfer learning comes in and saves the day. Transfer learning is when you reuse an already trained model in your new model. It's beneficial if the pre-trained model has been trained on a similar dataset or domain as the one that you are working with. Let's see what transfer learning looks like. I have selected a dataset containing microscopy images of blood cells, and I want to train a model to classify the different blood cell types. First, I will create a model without using transfer learning and train it to see what performance we can get during a certain amount of time. Then I will create a model using transfer learning, and I will train it for the same amount of time and see what performance we get. Here we can clearly see how much better model we get right away by using transfer learning instead of trying to build a model from scratch. The one we built from scratch here doesn't seem to be learning that much at all, and maybe it needs more data or more training time, but it needs more iteration. The model using transfer learning has a pretty decent result actually, and it got it very quickly. There, ML developers, using pre-trained models, in other words transfer learning, is a very powerful technique when building your models. And it's as simple as what I just showed you.